Hello everyone, welcome back. My name is Mr. Cobalt, and in this video I'm going to go over another problem. I'm going to use my Elmo, my dock camera for this one since it's a longer one and I can't really write it on the board and use the whiteboard like I usually do. So I'm going to switch over to my web camera or my Elmo, my dock camera, and start the problem there. Okay, so here's the problem. So you're given methanol, and which is methyl alcohol or wood alcohol, and they're telling you it's a potential automotive fuel, either pure or mixed with gasoline. So you can have methanol mixed with gasoline as a fuel. And it says some fleet vehicles, such as municipal buses, have been modified to burn methanol containing fuels. Okay, so these fuels are also used by some race cars. So now they're giving you some like background that's not really important. Now we're going to get into the problem. It says an automobile modified to use a mixture of 85.0% methanol and 15.0% gasoline by mass as a fuel gets about 25.5 miles per gallon of fuel. So this is how far the car goes per gallon. So 25.5 miles per gallon of this fuel, this mixture of 85% methanol, 15% gasoline. And then it gives you some densities. It gives you the density of the fuel, which is 0.775 grams per mil. It gives you the density of methanol, which is 0.787 grams per mil. And it gives you the density of gasoline, which is 0.703 grams per mil. And now it gets to the question: how many how many kilometers could this automobile drive on the mixed fuel if you are limited by your supply of 20.0 liters of methanol? So you're limited to 20.0 liters of methanol, and they want to know how many kilometers could you drive on this fuel. Okay, so what do we do? So the first thing you're going to do is you're going to pull out all the information. So remember, uh, percentages can be used as conversion factors. Densities can be used as conversion factors. So pull out all that information, all the relationships that they're giving you. So let's go ahead and do this. So they're giving us that this substance, this fuel that they're giving us is 85.0 percent methanol. So that means that for, and this is by mass. So by mass as a fuel. So that means that of the fuel, so for every, say, 100 grams of the fuel, that's going to be equal to 85.0 grams of the methanol. And the same thing goes for the 15% gasoline. So for 100 grams of fuel, then it's going to be 15.0 grams of gas. Okay. And so another way you could write it is it's 15. You could relate these together as well. So for every 85.0 grams of methanol that you burn, that'll also burn 15.0 grams of gas. So those are three relationships we could use. They also give us the densities. So they're telling us they're giving us that this fuel gets 25.5 miles per gallon. So if we write that as an equality, that means that for every 25.5 miles we go, that will be equal to 1 gallon of this fuel. Okay. And then we have the densities. So we have the density of the fuel. So that means that for every 0.775 grams of the fuel, that will equal 1 milliliter of fuel. And then for the methanol, the density of methanol, that's 0.787. So 0.787 grams of methanol. I'm going to abbreviate that meth. That's going to be equal to 1 milliliter of methanol. And then finally, the density of gasoline. So that's 0.703 grams of gas is going to be equal to 1 milliliter of gas. And those are our conversion factors, our relationships that we're going to probably use. Now, we may not use all of these, but they're there for us to use. And so now we need to figure out where we're going to end and where we're going to begin. So I'm going to draw my arrow. And so remember, the question is where you want to go. So the beginning and ending of your problem is most of the time in the question. The beginning of the question is the end of your problem. So if you look here, how many kilometers could this automobile drive? So that's the end of your problem. That's your goal. How many kilometers? So we want to know how many kilometers are we going to be able to drive? So where are we going to begin? If we continue in the question, how many kilometers could this automobile drive on the mixed fuel if you are limited by your supply of 20 liters of methanol? So this is where we're going to begin. We're given 20.0 liters of methanol. So we need to figure out that how far could we go if we're limited to 20 liters of methanol to drive. So that's where we're going to begin. So 20.0 liters of methanol. Okay, so now all we need to do is start with 20 liters and multiply by conversion factors until we get to kilometers. Okay, so let's get started. So I'm going to start over here because we might need some room here. So we're going to start with 20.0 liters of methanol over 1. And all I'm going to do is I'm going to multiply by conversion factors until I get to kilometers. So what's the first thing I need to do? Okay, so I need to convert liters to milliliters because you'll notice that I have grams and I have milliliters here. I don't have everything in liters, so I need to convert liters to milliliters. And again, to do that, I'm going to set up my equality. You're going to need to know your prefix multipliers. So I set up meters and kilometers. I always put the 1 with kilometers, and then the base unit gets the prefix multiplier. So I need to know the prefix multiplier for kilo. That is 1,000 or 10 to the third. So 1 kilometer is equal to 10 to the third meters. So now I have liters of meth here, right? Not kilometers. Oops, wrong one. Wrong unit, not kilometers, but millimeters. Oops, made a mistake. So I'll change this. Sorry, we want milliliters. I don't know what I was thinking. Here, I'll do this again. So I put my equality. I want milliliters and liters. That's what I want. And so the 1 goes with the prefix, and then the prefix multiplier goes here. And so since milli is the prefix multiplier, that's going to be 10 to the negative 3. So I have 10 to the negative 3, or 1/1000th of a liter. So that's my equality that I'm going to use as a conversion factor. So since I used my room here, let me start over. So I'm going to give myself some room here. So I have 20.0 liters of methanol. I'm just going to say meth to give myself some room, over 1. I'm going to multiply that by my conversion factor here. So since I have liters of meth on the top, I'm going to use this 10 to the negative 3. So 10 to the negative 3 liters of methanol. Oh, and then I'm going to put 1 milliliter of methanol on top. So liters of methanol cancel out. So now I have milliliters of methanol. And eventually I want to get to distance. I want to get to kilometers. So what do I got to do next? So I have milliliters. I could convert that to grams, right? And notice here I have miles to gallons. So if I could get that to gallons of fuel, but I have methanol. So I need to get to methanol. So if I could get that to grams, notice that I have a relationship here of grams of fuel to grams of methanol. So I could use that relationship to convert from grams to go from methanol to fuel, and then I could get to fuel to miles. So let's do that. So I'm going to use the density of methanol. So we're given the density of methanol here. So we know that 0.787 grams of methanol is equal to 1 milliliter of methanol. So I'm going to use that. And here I have milliliters of methanol on the top, and I am going to have milliliters of methanol on the bottom. So I'm going to put 1 milliliter of methanol on the bottom. So 1 milliliter of methanol on the bottom, and then 0.787 grams on top. 0.787 grams of methanol on top. So milliliters of methanol cancel out. Now I have grams of methanol. Now I can use the relationship of 100 grams of fuel is equal to 800 grams of methanol. So this relationship here. So 85. So since I have grams of methanol on the top, I'm going to have 85, put 85 grams of methanol on the bottom, and 100 grams of fuel on top. So grams of methanol cancel out. Now I have grams of fuel, but in order to get to distance, I need gallons of fuel. So gallon is a volume. So in order to get to volume, I'm going to have to go back to the density. So I'm going to now use the density of the fuel that they gave me. So now I'm going to have to use the density, since I know that the density of the fuel is 0.775 grams of fuel per milliliter. I have grams of fuel on the top, so I'm going to have the grams of fuel on the bottom. So this grams of fuel, 0.775. So I'm going to put 0.775 grams of fuel on the bottom and 1 milliliter of fuel on top. So grams of fuel cancel out. Now I have volume of fuel. I have milliliters. Now I got to get that to grams. I think or I have to get that to gallons. So I think the easiest way to do that would be to first convert to liters and then convert that to gallons from liters. So I'm going to continue down here. So I'm going to move this up. So I'm going to come down here. So I'm going to continue here. So this is probably going to be a long conversion factor problem. So again, I'm going to use my relationship milliliters to liters, but now I'm going to use it backwards. So I'm going to, since I have milliliters of fuel on the top, I'm going to have milliliters of fuel. So 1 milliliter of fuel, 1 milliliter of fuel on the bottom, and 10 to the negative 3 liters of fuel on the top. So milliliters of fuel cancel out. Now I have liters of fuel. Now I can use the relationship between gallons and liters. I don't expect you to have memorized that, so that's probably something you could just look up. So if I write it here, one gallon of is equal to 1 gallon is equal to 3.785 4 liters of whatever substance you're using. So we could use that. So since I have liters of fuel on the top, I'm going to have to put liters on the bottom. So that's going to be 3.7854 liters of fuel. And then one gallon of fuel on top. So liters of fuel cancel out. And now I have gallons of fuel. Now I can go back up here. I can use the 25.5 miles is equal to 1 gallon of fuel. So now I can use that as a conversion factor. So here we go. So 1 gallon of fuel is going to be equal to 25.5 miles traveled. So notice I have gallons of fuel on the bottom, and that's going to cancel out with gallons of fuel there on top. Now I have miles, but we don't want miles. We want kilograms. So again, I don't expect you to have that memorized, so you can look it up. So the relationship, if I was to write this down, the relationship between miles and kilometers is 1 mile is 1 mile is equal to, let's see, 1.6 kilometers. And so this would be our last conversion. So 1 mile on the bottom, and we have 1.60934 kilometers on top. Miles cancel out. Now we have our kilometers. So now all we need to do is multiply across the top, divide by everything on the bottom, and we'll get our answer. And so when we calculate that out, we get 259 259.035 and some change kilometers. And so now the last thing we need to do is figure out how many sig figs we're allowed to keep. And so you'll notice here they gave us 20.0. These two zeros are significant because they're at the end and there's a decimal point. So zeros at the end of your number are significant if there's a decimal point. So this has 3 sig figs. This relationship is exact. This relationship is a measure. So we have 0.787. That zero is not significant because it's at the beginning of the number, and those zeros at the beginning of the number are never significant. So we have 3 sig figs here. Here we have 85.0. So if we go back to our originals, 85.0, I forgot the zero here. So that should be 85.0. And that again is 3 sig figs. Here we have 775, 0.775. That's going to be 3 sig figs again. This is an exact relationship. This is 5 sig figs. Here again we have 3 sig figs. And here we have 6 sig figs. So the least number is 3. So you can only keep 3 digits in your answer. So 1, 2, 3. And this one is a 0, so we don't need to round the 9. So the final answer is 259 kilometers. So that is your final answer for this problem. So I hope you enjoyed that video. If this was very helpful and you had a good time, so let me know in the comments what you think. And if you like the video, please make sure you hit the like button over here and share the video with anyone else. And don't forget to subscribe to my channel. Thanks for joining me and have a great day.